Hello, my dear friends, uh, and welcome to another lecture on linear algebra. In this lecture, we will study about singular case. In our last lectures, what we have studied is we have studied row picture, column picture, and then we did some of the examples using Gaussian elimination methods. Now we will see when our equations will fail. Now, suppose that we have two equations for two variables. So we have two equations for two variables. Now in this case, there can be three cases. So let our first case be this. Suppose we have these two lines that they go like this. This is our A line, this is our B line. So they will intersect at some point. Now uh, let us make another case. Let the lines be this. These are our x and y axis, and these are our two lines. Let us name them C and D. Now let us take our third line of equation. So let me draw it here. So let us call it as E comma F. So both the lines are same here. So we have three cases. This is our first case, this is our second case, and this is our third case. Now in our first case, these two lines intersect at one point. In our second case, the two lines are parallel and do not intersect at any point. In our third case, these two lines intersect at infinitely many points. So they nothing but they overlap. So only the first case is a non-singular case. The rest two cases, that is case 2 and case 3, are the singular case. Similarly, we can have cases in three dimensions. So let us see our cases for three dimensions. Let me first now let us see for our let us see what happens in our 3D part. So for 3D part, we can take some cases. The first case be that three planes are parallel to each other. So let this be first plane, let this be second plane, and let this be third plane. So we are seeing this in 3D. So this will be a one plane, this is a second plane, this is a third plane. All three planes are parallel. Let us see our second case. Our second case is this, that two planes are parallel and one plane intersect these two planes. So we have two intersection points here. One plane is intersecting the other two planes. Let us see our third case. So in this case, let us assume this is one plane, this is another plane, and this is a third plane. So what we see here is that we have three intersection occurring between the three planes. So in all these three cases, we will not have a solution. So all of these cases are singular cases. So they don't intersect at a single point, and we don't have a non-singular case here. Now what happens is these planes are parallel to each other. so they don't intersect. The planes which intersect here, they form a line. So in our this case, when these two planes intersect, they will form a line. So let us consider this as a plane. Let us see this as another plane. So these planes will intersect at these 2 points. So it doesn't just intersect at 2 points. There will be a line at which these two planes will intersect. So uh, these two planes intersecting form a line. So this plane intersecting forming a line can give us the infinite solutions, as the whole line is a solution now. So we will have infinitely many solutions. Similarly, the only case that remains for a 3D equation to give us a solution is that if three planes intersect at a single point to give us a solution. Else all other cases will be the singular cases. This now we have seen in the row picture form. Now similar things can happen in the column picture also. So let us see how the things happens in the column picture. So let me first clear this. So we saw our things in the row picture form by making the lines and by making the planes. Now we will see them. We will see these cases in the column picture. So for that, let us take the set of equations. Let our set of equations here be x plus y plus z equals to 3, 2x plus 5z equals to 7, 3x plus y plus 6z equals to 9. So these are the three equations. Now these three equations form a singular case. As adding this, let us name this equation 1, this equation 2, and this equation 3. Now these form a singular case. How do we know that? Because when you add the left hand side, so let us add the left hand side and then we will add the right hand side. Um, so on adding, what we get here is that now we don't add all the equations, we add equation 1 and we add equation 2. So adding these two equations, we get 3x plus y plus 6z, this is equals to 7 plus 3, that is 10. So we get the left hand side which is equal to equation 3, but the right hand side is not equals to equation 3. So what happens is that these two equations will form a line that will be parallel to this plane. So they are forming a plane that is nothing but parallel to this plane. So here our column picture also breaks. So these equations are parallel, that is equation 1 and 2 with respect to equation 3. So as they fail in the row picture, they will also fail in the column picture. So let us write these equations in the form of the column vectors. So how do we write them in the form of column vectors? Nothing but we take x here. This will be 1, 2, 3 plus y 1, 0, 1 plus z 1, 5, 6. This will be equals to 3, 7 and 9. So in our column picture we have three vectors here. So if we have only a single combination of these vectors forming this portion, then it will be a non-singular solution. Else it will be a singular solution. So if we have a unique x, y, and z for this solution, then it will be a singular case. Else it will be a not singular case. So let us call this vector as b vector. So if these three vectors 1 2 3 1 0 1 1 5 6, these vectors will form a plane. Now if this b vector lies inside this plane, then what happens is that we have infinitely many solutions for b. But if this b lies out of the form plane, then we will have a no solution case. So for b equals to this 3 7 and 9, we have no solution case. But what happens is, if we have b as 3 7 and 10, that is, this instead of this 9 we write 10. So for this we will have infinitely many solutions. So our question is, how do we know that three vectors are going to form a plane? So um, how so for that the answer is that if some combination of these three vectors produce a zero vector, then we know that they will form a plane. So here, so let me first rub this. So if these vectors will form a zero vector, then we know that they will form a plane. So here that combination is 5 comma minus 3 comma minus 2. So we will see this in further lecture, how do we get this so that we get the zero vector. So let us first put 5 minus 3 and minus 2 in place of x, and then we will compute this. So it will be 5 minus 3 minus 2, so it will be 0. 5 times 2 10 minus 0 minus 2 times 5 10, so it will again be 0. 5 times 3 15 minus 3 minus 12, so it will again be 0. So this combination 5 minus 3 minus 2, this gives us a zero vector. So 5 times column 1 minus 3 times column 2 minus 2 times column 3, so this will give a zero vector. So here only two columns are independent, that is, the combination of these two columns will give us a this will give us this first column. So only column 1, only column 2 and column 3 are independent, or we can say that column 1 and column 2 are independent, and some combination of these two columns will give us this column. So now if we go to our previous case, that is 3 7 and 9 for our b vector. So here we have 3 7 and 9. Now here we have x y and so some combination uh, should give us this 3 7 and 9, but we know that adding equations on the left and adding equations on the right does not add up, so we won't have a solution. So for this case we have a no solution case. So this is a singular case with no solution. Now instead of 9, if we write 10, so adding of these two rows gives us the last row. So instead of no solutions, we will have multiple solutions, because one of these variables will be a free variable, and then we can have multiple solutions in this case. So uh, what we let us continue with this case of 3, 7 and 10. What we see here is that if x is equals to 1, y is equals to 1, and z is equals to 1. So what happens is that 1 plus 1 plus 1 gives us 3. 2 plus 5 gives us 7. 3 plus 1 plus 6 will give us 10. So our solution for b equals to 3, 7 and 10 is nothing but 1 comma 1 comma 1. But we also know that some combination of x, y and z gave us 0. So that combination was 5 minus 3 minus 2. So what we can do here is, if we can just add some let us say lambda times the vector 5 minus 3 minus 2. So this is going to always give us a 0 vector, and then we can add 1 1 1 to our original part, and then we can always get 3, 7 and 10. So let me just repeat that portion. So for 3, 7 and 10, this 1 1 1 vector will always produce 3, 7 and 10, and 5 minus 3 and minus 2 always produce 0. So if you add 0 to this vector 1 1 1, you will always get this vector. So this is nothing but plus 0 0 0. So this lambda times minus 3 minus 5 minus 3 minus 2 is solution for this 0 portion, and this 1 1 1 is a solution for this 3, 7 and 10. So this case we call a particular solution, and this is a null space solution that we will see later on. So our overall solution for this case is nothing but 1 1 1 plus lambda times, or you can put here that c times 5 minus 3 and minus 2. So we see that as our row picture breaks, our column picture also breaks. Now if here we had 10, so what would have happened is that the combination of these two will be a uh, the combination of these two gives us this third equation. So we will have a line of whole solution. So this is our line of whole solution. So this is nothing but a line which so this will be a line of our whole solutions. So this is nothing but 1 1 1 plus lambda times 5 minus 3 and minus 2. So till now we have seen our row picture, column picture, Gaussian elimination and singular cases. In our next lecture, what we will see is the matrix notation form. So I hope you got this singular cases. So let me summarize it for you. So if we have a no solution case or multiple solution case. So for this case, these are a singular cases. But if we have single solution, then it is a non-singular case. In our further lectures, we will see how to get the solutions. So here I just showed a part of a part of the solution. In our next lecture, we will see how to get those solutions. Like you saw some vector plus lambda times another vector. So we will see in our further lectures how to get this lambda times another vector and the particular solution. In this lecture was mainly focused on singular cases and non-singular cases. So that is all in this lecture. Uh, that is all in this lecture. I thank you for watching the lecture. Please like and comment your doubts so that we can solve those doubts on time. So that is all in this lecture. Thank you for watching.